So I've taken the main board out to replace the switches. So these are common switches that fail, the tap and the start stop. So we just pull the caps off, and these are nearly impossible to get now. So I've come up with a workaround. What I do is I get these, which are push switches that are used on the DD3, SD1, basically the Boss pedals, which are readily available. Part number 510024133. And what they have is a little cable clip on the top, which you cut off, and then I also just file each of the flats a tiny amount, like we're talking about a fraction of a millimeter, because the size of the end shaft is slightly different from the original. So I just file that down a little bit. I just use a little hand file like this, so that I end up with a switch like this. So here it is with the clip trimmed off, and it's slightly filed down on the edge, and this will fit perfectly into the start-stop switch. Now these only have 2 pins on them, whereas the original actually has 2 on one side, 2 on the other. So what I'm going to do is pull this out. I'm going to mark the top of it so I know which way it came out, and then I'm going to check the continuity between the pins so I can work out how it's connected in circuit, and then I can simply run some wires from one to the other to make it like a 4-pin switch. So let's do that now. So looking on the other side of the board, this is the switch position here, and you can see that actually this one is not contacted at all. Either is this one. It's just this one has a track going up, and the other one on the other side, if you flip it over, you'll see here that it has a track there on that switch pin. So if we just make sure that when we put our new switch in, the pins go on top, that should do the job. So at the same time, if we look over here on the left hand side of the board, this is the tap switch position, and you can see how this makes contact between here and the top pin when you push the switch down. So when we put this in, we'll just make sure that the pins go in that way. Now to get this switch to fit, what I've had to do was turn the pins around slightly, turn them sort of 90 degrees, and then bend them over so they're flat bent down. And then that will be able to go exactly in that position. And what we want to do is solder it from the top to get it attached, and then on the other side I will solder it as well. Just to show you that the tap switch is dead, I've got it on my ohms reading, and I've got the top and the bottom pins here connected, and when I hit this it should go to 0 ohms because they should actually be connected, but you can see I get nothing. If I really squeeze it, I can get it down to 2.5 mega ohm or something like that, and then it won't go back to 0 again. So yeah, that's dud. That needs to be replaced. So to show you how a good switch should work, when I have the pins connected across there, when I press the button, it should get 0 ohms because it connects the switch. So that's what we should be getting. So that's done. So I've cut the tabs off this one, and I'm going to bend the pins, and then this is going to go into my tap position. For the tap button, what I have to do is solder some wires on the other side, bring them through the hole, and then give myself a little spot where I can attach the pins to. Now this goes a different orientation. This one we're trying to connect these top ones to the bottom ones. So what we actually want is for it to be in that position, or that position down, so that when it connects these two parts together, but we don't want them to touch this board on the top side. So we don't want them to touch the top side of the board, so it's going to go in this position up and down, and we have to bring some wires through the board, so I'll do that now. So this is the fiddly part. What you have to do is cut some wires, feed them down underneath, solder them underneath, and put some insulating stuff on them that you can then pull over the pins. And then what we're going to do is solder these onto those pins and then insulate them so they can't touch the surface. And we'll put some hot glue on the center, put that in the middle, and that will hold it in place. Now, our switches are in place, start, stop, and the tap. I've just used some hot glue to sort of pot it so it can't come loose, but that should be okay. And let's connect it back up and see how it works. So to get these switches right, in the right position, what I did was put a dab of hot glue on the bottom of them, both of them, then put the case on and then push them into position and held them there until it sort of dried. It took a minute or so just to make sure they get in the right position. So they go through the hole. They sit a tiny little bit higher than the previous ones, but it's no problem. They work great. So they're in. Let's do a switch check before it all goes back together. So start. No, start. Stop. Start, stop. So I think these switches are new, but they've been probably sitting in stock for ages. So they probably need a bit of a spray and then a bit of use before they work 100% every time. But the tap one is fine. So that's working. So should be good. Put it all back together and give it a good test. I find that window cleaner is great for cleaning these. Get it really nice and clean before you put it back on so the switches don't get in the way. It's sort of, the paper is slightly abrasive, which just helps clean it. There we go. Let me ease it back into position. That. So this button's still a little bit flaky. So I might actually put a crow on this and just check what's happening when I start and stop it. So I've discovered what my stupid fault was. What I've done is when I put the switch in, I've put it around the wrong way. So it's been acting erratically. Because it's actually 2-pin switch, this one, whereas the original was 4, you have to be careful with the orientation. And just to show you, here's the old switch. So if the switch works properly, I should be getting this on the screen, so a direct short. And normally it's in an open position. When I press the button, you can see it only slightly works. So showing that it has way too much resistance and it wasn't closing properly, which is what we know is wrong. It just wouldn't start the machine sometimes. So what we should be getting is this on the switch. That's what a new switch should look like. So here's our new switch in, and the way I've had to wire it was pins to the right hand side. One lead goes to the top pin, the other one goes to the bottom pin, and then underneath I've just basically tracked across 2 tracks going across underneath to connect them so that when you press the button it connects the top to the bottom and to the sides as well, so to make contact. So now when I press the switch, start, sequencer starts, runs right through, hit it, stops. So that's what we want. So that was the problem. So here's the underneath side with the tracks run across. I went straight from one track to the resistor because one of the pads for the switch had come off, which is really common with these old circuit boards. So I just went directly to the component. So that's done. Okay, it's amazing what a difference it makes when you've got the switch around the right way. So now we should have reliable stop. And the tap. Fixed. So I've got another one of its siblings here for repair as well. Can you guess what it is? Here's a bit of a sneaky. Any ideas? Look at one of the switches. What do you think's in the bag? Anyway, that's coming up soon for repair.